Hello and welcome. This is going to be our lecture video for February 3rd through 4th. Let's go ahead and get started, get those notes out. For your do now, I want you to try to create the image of a rectangle on a piece of graph paper out of just equations. And by rectangle at an angle, I mean not one lying flat out of just horizontal and vertical lines. I want you to try to do it out of lines with slopes. All right, so try that on your own. Now I'm going to show you my example. So I can start with any line. So maybe I'll pick a y-intercept of 6 and a slope of 1/2. That makes it really easy to write the equation of this line. All right, that right there is the line of y equals 1/2 x plus 6. All right, now rectangles have two sets of parallel lines, so I'll need another line parallel to this one, and if it's going to be parallel, it has to have that same slope. So I'll just pick a different y-intercept, like maybe 2, but then I'll keep that same slope, and then I'll connect this up, maybe a different color line. All right, and then I'll write the equation for this one. This would be y equals 1/2 x plus 2. So same slope, but different y-intercepts gives us two parallel lines. So we're halfway there. Now I've got to figure out the slope of the other two lines, and we know that at a rectangle, all of the corners are right angles, so all of these lines have to be perpendicular. So I need a slope perpendicular to 1/2, so I need to find the opposite reciprocal of 1/2. So what I do is I take 1/2, flip it upside down, I've got 2/1, and then make it negative 2/1. This can be simplified to just a -2. So one thing I know for sure is that my equation will have to have a slope of -2. All right, maybe I'll put the y-intercept at 8. Slope of -2 means go down 2/1. And I've got another line. This is the line in green. Y equals -2x plus 8. And now the other side of this rectangle has to be perpendicular, or perpendicular to these two lines, but parallel to this one, so it has to also have a slope of -2. So we'll pick a different value for its y-intercept. Maybe we'll put it up here at 12. Give it a slope of -2. And this should look like a rectangle. Right in the middle there. And that last equation was y equals -2x plus 12. It crosses at the 12. All right, we'll shade in our rectangle, make it very clear where our shape is. It's right in here. Okay. Goal for today is to be able to write the equation of a line given a point and a slope. Why do we need to do this? Well, one thing I thought of is you could use this formula anytime you need to hit a target with a line of a specific slope. So you could use this in archery, trying to figure out where you need to stand to shoot your arrow to hit a certain target, or maybe aeronautics, where you're launching a rocket and you're trying to hit the moon or an asteroid or something, and you want to know where you should launch your rocket from and all the other information. You could use point slope form to at least get you started. There's a lot of great math in aeronautics. So what is point slope formula? So first, let's give a definition of what it does. Point slope formula is a way of writing an equation when given a point on a line and a desired slope. So essentially you've got a graph and we just know a single point that has to be on that line. So this is, we'll call that point x1 comma y1. All right, and we're going to try to hit this point with a line, but the only thing that's important about that line is that it has a fixed slope. So try to draw this a little straighter. So the only thing we know about this line is its slope, and we can get that with maybe a slope triangle. But we don't really care what the y-intercept is. We don't care what any of the other points are. All we care about is that this line has a certain slope and hits a certain point. So if a line goes through x1 comma y1 with a slope of m, the equation can be written as y minus y1 equals m times parentheses x minus x1. If a line goes through x1 comma y1 with a slope of 1, the equation can be written as y minus y1 equals m times x minus x1. X and y will stay as variables, but m, x1, and y1 will all get replaced with numbers. All right, so let's put this to the test. Can we write the equation of a line with a slope of 10 that passes through negative 4 comma 3? So that 10 must be our m value. The negative 4 comma 3 is going to be our x1, y1. All right, let me write down my formula again. Y minus y1 equals m times x minus x1. And now I'm just going to substitute all three numbers in. So y, again, just stays as a y. Minus y1 is a 3. Equals m is a 10. Times x minus x1 is a negative 3. So we have minus a negative, or it's a negative 4. Minus a negative 4. So don't forget the minus from the formula and the minus from the number. That's why we get a double negative there. All right, now the whole point of doing this is to get an equation that will definitely go through that. But then we typically want to convert this to slope-intercept form. So let's go ahead and do that. So here is our point-slope form equation. Point-slope form. But let's convert it now. So one thing is that minus a negative can become a plus. So y minus 3 equals 10 times x plus 4. We can get rid of the parentheses by distributing it in this 10. Y minus 3 equals 10x plus 40. And then we can isolate the y by adding 3 to both sides. So plus 3. And now we get y equals 10x plus 43. And that right there is slope-intercept form, which is easier to graph from. So typically point-slope formula is just a stepping stone to get us to slope-intercept form. So, we've got a stepping stone. All right, now what if we're given a picture of a graph? Can we write the equation of this line? We can see it goes through 3 comma 2. and it has a rise of 3 and a run of 1. Is that enough information? Well, yeah, because we can turn the rise and the run into a slope. So m equals rise over run, which equals 3 over 1 in this picture, which can be simplified to just a 3. And then 3 comma 2 can become our x1, y1. Now we have everything we need to plug it into the formula. Y minus y1 equals m times x minus x1. So y minus 2 equals 3 times x minus 3. And again, we just want to use this as a stepping stone to get to slope-intercept form. So y minus 2 equals 3x minus 9. Then add 2 to both sides. And we get our equation in slope-intercept form, y equals 3x minus 7. And then check for reasonableness. This says our y-intercept would be negative 7. If this line kept going, does it look like it would cross the y-axis at about negative 7? Yeah, that's very believable. All right, we can't see it exactly, but at least it's not a positive number, too big of a negative number. It seems about right. All right, so here we've got 2 points, but no slope. Well, we can find the slope in between them. So connect these with a slope triangle. Well, sketch it in your notes first, then connect these 2 points with a slope triangle. Now if I go from this point to this point, I have to go down 1, 2, 3, 4. All right, and then I'm going to go over 2. All right, then that's our rise and that's our run. So rise over run becomes negative 4 over 2, which can be simplified to just a negative 2. We just complete the division there. So that's our m value. And now what do we do for an x1, y1? Well, we can actually pick either of these points to label as x1, y1, and it will work out. We get the same equation either way. And it'd be a good way to double check is to do it with both points and make sure you get the same equation. All right, so y minus y1 equals m times x minus x1. Let's fill in what we have. Y minus 6 equals negative 2 times x minus 1. So the 1 and the 6 went there and there. And let's convert this to slope-intercept. Distribute the negative 2. Y minus 6 equals negative 2x plus 2. Add the 6 to both sides. Y equals negative 2x plus 8. And you can try it again with this point. We should get that same equation, or just plug these points into this equation, see if it balances. Negative 2 times 3 is a negative 6, plus 8 is a 2. We put a 2 on the other side, so 2 equals 2. That's a good way to double check. So we'll double check it. Double checked with that point. All right. And lastly, we're going to do a word problem. You start a business cleaning pools in the summer. You buy some equipment. So you were starting at a deficit, but then we start cleaning pools for $50 per pool. After cleaning 4 pools, you have only netted $35 in profit. Write an equation to represent your total earnings. Y for cleaning X number of pools. So a few things to pull out here. The $50 per pool, that is our rate of change. Anytime you see that word per, that tells you that each time you're moving 1 to the right on your graph, you're moving this amount up or down. So this has got to be our m value. Now, they give us this fact that after cleaning 4 pools, we have $35 in profit. So that gives us an ordered pair, 4, 35. All right, because X is supposed to be number of pools, Y is supposed to be earnings, so 4, 35. All right, let's label this x1, y1, and then plug it in with the 50 into our formula. Y minus y1 equals m times x minus x1. And we get y minus 35 equals 50 times x minus 4. And let's get this into slope-intercept form. So distribute the 50. Y minus 35 equals 50x minus 200. Add the 35 to both sides. And we get that our profits, y, will be equal to 50x minus 165. What does that 165 represent? That is the cost of supplies. Because remember at the beginning we said we bought some supplies. Well, that has to be factored into our net profit. And so we didn't know what it was until we did the math, but we realized we spent $165 on supplies. So basically for the first 3.5 pools, we were just recouping that investment, and from here on out, it'll be all profit until we have to buy more supplies. All right. Now that we have an equation, you can plug in any number. We could plug in a 10 here and see how much money we would have after cleaning 10 pools or 20 pools, and so on. All right, that'll be the end of this lecture video. I'll bet a few more questions here, and have a great rest of your day.